Yes, thank you. Hello, everyone. So I am Renal Bera, the lead beamline scientist for the ASWAXS, which is anomalous small angle and wide angle X-ray scattering facility. So there's from the slide you can see that this will be located at the end station. Some of the users which have come over here to do experiments already know about it. But now, when you will come again later next year, you will see totally upgraded ASWACS instrument. So I will briefly talk about all the developments what we have been doing so far. So what is ASWACS? Just to give you a brief overview. So ASWACS is a technique, very powerful technique, which can provide you statistically average elemental distribution within soft matter and nanomaterials. Uh, which has a short range order with sub-nanometer resolution. So what can you do with this? So we have been working with our users and we have broadly classified the problems into three major categories. One is supramolecular chemistry, solution chemistry, and functional nanomaterials. So under supramolecular chemistry, what you can do is you can look into some specific ion interactions with the supramolecular backbone. For instance, here I'm showing you a cartoon of DNA interacting with silver ions. So you can look at those kind of problems, and basically it will give you information about the material itself, how it interacts with ions, then ion selectivity, and to some extent give you some targeted drug delivery information also. In the solution chemistry, we are targeting like ionic channels, electrolytes, and charged macroions. The cartoon you are seeing is our recent work where we can see, how ion interacts with cellulose nanocrystals. So all the solution, interaction within the solutions you can probe with anomalous small angle X-ray scattering. The third broad category is the functional nanomaterials. Nanomaterials now comes with, different kind of elements, multiple elements fused together to give you alloy kind of systems. So all those kind of nanomaterial you can probe where you need elemental sensitivity. So in particular, we are looking into up converting nanoparticles, which are giving you unique optical properties, multi-component nanoparticles, and some of the recent ones are metal oxo clusters, which the cartoon it shows like how ions interact with those metal oxo clusters in solution. So with that broad scope of science, which we'd like to do, here in the SX facility, we are providing a very optimized beamline optics, which is necessary for collecting such a, such amount of SAX data, which is collected over energy range. So what you need is a huge tunable energy source, which our beamline provides. Here we are using mostly like 5.5 to 70 keV in our 15ID1 line. We have a very nice energy resolution, which is below 1 EV. And with this kind of energy resolution, what we can do is probe more or less all the elements above Z equal to 25. So that gives us a broad sense of, elemental sensitivity. But the thing which becomes very important after the APS upgrade is we are getting some smaller beams and brighter beams. So I'm going to talk about that aspect in the later slide, how we can use that aspect of the APS upgrade. With that, with the current capability, what we are doing is we have upgraded our ASACS, system completely. So if you have come here before, you know that there is a big tube which is giving you, Q range, which is limited. But now with the new system, which will be available in 2026 summer, here you can get tunable Q range, and both SAX and AVAX combined you can do together. That is a simultaneous SAX-VAX capability. On top of that, we are providing a huge range of sample environments, including ambient condition and temperature controlled environment, which we already have been tested before. On top of that, we have also worked with our users to do some custom sample environments. For instance, here the electrochemical setup and the pendant drop setup shown on the right. With the as I mentioned, the new upgrade, what we are getting after APS-U is smaller and brighter beams. So we would like to use this capability to look at the small sample environments, as Mark already mentioned about it. So what we want to do is, so far, ASWAXS experiments is very time consuming. So people have done only static measurements on systems. Now with this smaller availability of smaller beams, we can put into smaller sample environments. For instance, the microfluidics, where people have done already SAX measurements to show that it can provide you time uh, resolution. So what you can do here, from which the cartoon shows, you can do experiments where you can mix solutions together, you react them, and then study over the length of the microfluidics channel. So that's what we are trying to do here. My postdoc with Jiajun Tian, whose picture is here, he is working hard on make this thing available to the users from 2026, summer 2026. On top of that, not only we can do time-resolved ASACs, we are combining the UVVs and Raman to look at the sample in all possible ways. So we are integrating those things, and we have developed the hardware and software capability to include all the things together. So that will give us a capability to look at chemical reactions, time resolved chemical reactions, especially the nanoparticle formation. Then there are a lot of problems where people like to know how protein interact with metals. Those kind of research we can do. Another thing which we are trying to look at is the chemical separation processes, kinetics of that. So all these things can be possible by combining this microfluidics environment with the existing ESX capability. So that will be something which will be our users will be getting it from summer 2026. Another important capability which is going to be very useful for the users who are mainly working with nanoparticles on solid surfaces. And we will be providing a grazing incidence geometry where people can do anomalous X-ray scattering from grazing incidence geometry to look at the nanoparticles at very shallow angle, which gives you interfacial sensitivity. And this can provide element specific structure of nanomaterials on solid surfaces. On top of that, people can also use in situ catalytic reactions, which involves nanomaterials. Also, we are trying to look at some of the problems of electrochemistry, which deals with nanomaterials near the solid surfaces. So this technique will take some time to go through some iterations. So this we are kind of thinking about commissioning it in the fall of 2026. So this will come little later next year. So one of the things which makes our beamline separated from the other beamlines is we are providing, as Wei already mentioned, that we are not only providing the hardware support, but we are also providing the software support. And in particular for ASWAX measurement, what is important is means you can do the experiments somewhere else, but also what you need is correct set of software tools which you need to analyze the data to get the information out, which is not available anywhere. So here we are bridging that gap. We are putting a huge amount of effort in putting a hardware and software support. We have developed a data collector which combines all the UV-based ASWAX and Raman scattering data together. At the same time, I think some of the users have already used XModFit in not only in ASX but also in the liquid surface community, which gives you a sense of how a sample can be analyzed in a meaningful way to get the information out. So these are very easy to use software which is developed in Python and are available from our GitHub account, as mentioned here in the slide. So with that, I think we are going into a very exciting future for ASWAX as well as for the ChemMatCARS. So in the 2026 summer, we will be providing you with a new ASWAX facility with a new ASWAX sample, new ASWAX system. On top of that, we will be providing you some complementary techniques, which is UV-Vis and Raman scattering, which will be integrated with the ASAX measurements. And of course, the data collection and data analysis software will be improved and available. And on top of that, fall 2026, we will be providing you with the grazing incidence ASWAX geometry, which will be nice for interfacial studies. With that, I will like to thank everyone.